Hey community, Aubrey here with DevCentral. I'm coming to you from AppWorld 2025 in the fabulous Fontainebleau in Las Vegas. And if you're not here, maybe try to make plans for it next year. This has been a heck of an event so far. And if you were here at AppWorld last year, you'd see a ton of changes in terms of how this event went. A lot more social activity from my perspective, and we're bringing you as much of the coverage as we can. So hopefully you're following that on all the social places. I am here today with Daniela Pontes and Brett Walmerans from F5, who I think your community probably already knows. Brett, he's been here forever, like myself. Yeah, and so how's the AppWorld going for you guys?
Oh, very impressive. I really enjoyed the sessions today in special to see how F5 is leveraging AI both for what it can offer in optimization, in making things faster, better, but also putting the guardrails in place so you stay safe.
Yeah, and that's been kind of the talk. The AI Gateway was released, went GA yesterday, I think Ed said.
Yeah, GA yesterday.
That's beautiful. I know a lot of people have been itching to try it out, and it's been neat watching people actually play with it on the floor. So that was something that, as an AI buff myself, I was really looking forward to that, and it's nice to see it happening finally. We've been talking about it for months.
It's here.
Finally, and we'll have to get Ed on to talk about that at some point. I can't get him in front of a camera though.
Oh, he's
Ed, I'm coming
eager
for you.
to come. I'll help you get Ed out here.
Okay, I'll hold you to that too. But we're not here to talk about AI, right? Today we're going to talk a little bit about post-quantum crypto, which is something that you have spent some time with, is my understanding, Daniela. Yes.
Yes, quantum in general, interests me a lot. Together with AI, this technology will lift every industry from the bottom. Yeah, so there is no place to hide.
No.
You will face this change sooner or later.
And now, I think that most people don't understand that there may actually be, you hate to give anyone unnecessary fear, but there is a bit of a threat out there today right now, right? I mean, we do have quantum technology out there that is in the hands of some nation states and things like that. There are bad actors who have this tech already. Can you maybe elaborate on that for the community?
Yes. Let me step back. So quantum as a technology, you have it in three main domains. One is quantum computing, another one is quantum communication, and the other one is quantum sensing. All of them will deliver wonders. With regards to quantum computing, we know that once it reaches a certain level of computing capacity, it will break today's public key cryptography. So that is the looming threat. Yeah. What is the time frame? Yeah. So it's expected that between 2030 and 2035, we will have what is called cryptographically relevant quantum computers. Those quantum computers will be able to use like Shor's algorithm to break RSA, elliptic curve, Diffie-Hellman, which are the algorithms protecting today your secure internet, web browsing, online financial activities, your emails, your VPNs, all of these, your secure SSH remote access. So imagine your entire digital world will be at risk. So, do we have to wait until that kind of capacity emerge from everything that is being in works today? No. Why? Because it is expected that will happen in 5 to 10 years. So a lot of those bad actors are already collecting data, collecting data from the internet, targeting the industries that they want to, to breach. And who are those? The usual defense, healthcare, finance, all of this of critical infrastructure.
Critical infrastructure, yeah.
The bigger the disruption, more attractive is for them. So they are collecting this data and waiting for when they have the capacity to break the crypto protection. So that's what is called harvest now or store now and decrypt later. So the threat is real, the risk is real, and the attacks to a certain extent is already happening.
Now, I don't know if you saw this. We didn't talk about this before the recording here, but it occurred to me while we were chatting. On one of my podcasts, we talked about there was a group recently who claimed to have actually already broken 32-bit RSA with quantum crypto. That's scary on its own. Of course, we had a couple security experts on my podcast saying, well, that's RSA and 32, who cares? It's going to be another 20 million years before we get, crack Diffie-Hellman or elliptic curve cryptography of any sort. But it may not be that far away. You're saying 30 to 35, we could be in trouble. Okay.
Actually, that news came from China. They are quite advanced in quantum communication and, catching up with quantum computing. And it's true. Yep. It was not a real break of RSA, but it was a pretty good sign that there are ways to get there. Yeah. So the key size was
tiny.
And thanks God,
Thank you.
Key size in cryptography really matters. So they didn't get to the encryption key or to the data, but they use a very ingenious way to start putting some cracks there.
So I guess is there let's say a lot of our customers are in, say, financials and things like that. Is there an existing threat today? I think you've got CISOs. I talked with a CISO earlier today, and I'm wondering if he should be worried about his banking infrastructure at this point, and what threat quantum can have on his existing keys today. It's just not a threat yet, is what I'm hearing.
No, that's not the case. And
No.
it
Okay.
is already a threat. And the financial industry, it's already doing a lot. There are a lot of banks at HSBC, JP Morgan.
Right.
I see in the news a lot of them in Asia. A lot of them are already investing, getting together with telecom players, and not only thinking about using, the quantum resistant algorithm that NIST, published last year, but also using quantum technology to support tamper-proof encryption. So this is what is called quantum key distribution. So with that kind of technology, you can actually make sure that when you share an encryption key, if somebody tries to intercept it, the quantum technology tells it happened. So you can just say, discard that, we can try again. So there is a lot of that is underway, pilot, and also in operation today.
So then what can people do to try to defend against this today if they don't have anything special in their infrastructure? Is there something that people can do to help protect from this threat today?
Yes. So NIST published last year 4 standards that are that have been under evaluation since 2016. Yeah, and they are considered quantum computing resistant. Yeah. So you have the ML-CHEM, which is called a module lattice key encapsulation mechanism. The name that was before that people may be familiar with is the Kyber algorithm. And they release also, and that one was under FIPS 203, so it's a standard. There is another one that is for digital signature, which is ML-DSA. It was the crystals lithium before. And they also this is FIPS 204, and there is another one that is an alternative for the module lattice type of algorithms, which is the hash-based DSA. Before was Sphinx Plus, and that is the 205, FIPS 205 standard. So with that, you can start taking action. So I give you an example, and you can get help, both your vendor like F5, but also open source community. The Linux Foundation started the PQC Alliance, and PQC Alliance has a open source project. It's called Open Quantum Safe. And under this project, they are already creating libraries to implement those algorithms. Yeah.
Thanks.
And that can be used for TLS, which is your secure internet browsing, email with SMIME to protect your email, SSH. So there is a lot of being doing, and there are a lot of members that are using those libraries and implementing them in their own product.
Well, speaking of implementing in product, Brett, you work with our product quite a bit. Is there anything that F5 can do today that's in line with some of this defense?
Yeah, so what's pretty cool is actually with Nginx R33, we released quantum cryptography support for basic Kyber suites at the moment. And then I was actually just looking today, there's a new KB article on we're now supporting the Kyber algorithms in TMOS 17.5
Wow.
for big IP. And I know this because I'm reading a DevCentral article showing how to actually generate these PQC certs for Nginx R33 and get them enabled.
Wow.
So I can't wait to play around with myself. This is getting me excited about quantum.
Yeah, and no joke that that date stamp was today. So we did that came up, and we will include a link for you out there, community, of course, with that.
And shows how fast everything is happening in quantum.
Yeah.
Today I was telling I released the newsletter yesterday talking about Microsoft announcement of Majorana 1, their first chip, that has big promise in terms of addressing key challenges in quantum computing and reaching the volume that is expected for practical application, 1 million qubits in one chip. Yesterday, today, Amazon announced their first chip as well with a very innovative architecture. On top of this movement in terms of innovation at the chip level or qubit architecture to make it more error resistant, there are players acting on error correction, and there are players acting on algorithms. When you compound this, this timeline, between 2030 and 2035, we may have something earlier than that, and actually Bill Gates, said could be even in 3 years. It's possible because a lot is happening, and the pace, there is an acceleration in innovation in quantum.
So we talked about quantum, essentially quantum-resistant algorithms, but we also talked here about chips. Do you think that will people need to have custom hardware in the future? I mean, is that everyone's going to need to have some sort of quantum hardware to defend in the future, you think?
That's a very good question. So as you start the journey to create a plan, for you to migrate to quantum safe or PQC, post-quantum cryptography, you need to understand the impact that will have on your application, your services, the performance of how things are going to the performance of your application. Yeah, because quantum algorithms, quantum resistant algorithms, they are definitely heavier. Yeah, the keys are larger. The computational requirements is higher. So you need to understand that. So it is important to understand the impact and consider implementing, of course, in hardware to accelerate that, to reduce that kind of impact.
So we saw with artificial intelligence, we saw this rise of GPU as a service that became a thing like overnight. It seemed like in the cloud. Is there that kind of service today for quantum chips? Can someone go, get an EC2 instance and it's got quantum chip available? Is that something that is there today?
Quantum computers are a very unique thing, yeah. But they are already accessible via internet, cloud. IBM has, for a while already. AWS offers too. Google offers as well. Even the smaller players have Rigetti and others, they have that kind of disponibility. So I have already run a small quantum program on IBM Cloud. So it already exists. What the next step is to make it scalable, and to reduce the error rates and making it give more qubits for you to implement your algorithms. So we expect to have that by 2030 with the pace of innovation that we see, that we'll have that kind of computational, quantum computation availability for you to implement algorithms that will deliver practical applications with quantum power.
Okay. Now, real quick, before we kind of wrap, you mentioned the newsletter. I wanted to give a chance to kind of discuss what that is, what's it called, and where can our community find that?
Okay, so the newsletter is called Intriguing Quantum. I publish in LinkedIn. It's a bi-weekly, but I'm considering to make it now weekly because I see that there is a lot going on, and I want my community to understand, the announcements, the news, in a way that is easier to digest. Yeah, quantum by no means is something very easy to grasp, but it's absolutely fascinating, and I invite everybody to embrace because that's the future.
Awesome. And David Warburton, that last comment was directed at you, buddy. I know you love the quantum stuff too. So, okay, well, this has been really informative for me and for the community, I think. Thank you so much, Daniela, for spending some time with me today. And Brett, always great to see you, sir.
It was great to be with you, Aubrey.
Thank you for this opportunity. I enjoyed a lot.
You bet. The community, thank you for listening. And if you're not, like I said, if you're not here at AppWorld 2025, maybe check it out next year. It is an amazing event with lots of learning opportunities and great people to spend some time with. So thanks for tuning in. Don't forget to follow us on LinkedIn, on X, on all the other places. And we'll hope to see you out there in the community. Bye now.
Bye for now.